Today we're going to continue talking about solving compound inequalities, and we're going to talk about two different methods for solving, and you'll see both of them listed there. You have two different options. So with the first one, we're going to do example 1 using option 1, and we'll do example 2 using option 2, and you can decide which method you would prefer to do for each of these. Okay? So the first option is to set up the intersection of two inequalities. So basically what you would do is you would create two separate inequalities. So this would be the first one, because notice we do have two inequality symbols within the same problem. Okay, and so what you would do is you would go ahead and solve this one over here. And then you would also set up and solve this inequality. So basically everything except the inequality symbol for this side, and everything except the inequality symbol and its answer for this side. So we have two different problems that we set up and solve, and then we will find the answer at the end that is the combination of those two. Okay, so let's go ahead and solve the red one first, and so we'll go ahead and start to isolate the variable using inverse operations. And so we have x and -3, so we have -3 is less than x, and I usually like to rewrite it so that x is first. So whichever way this is opening will be the way that it's opening there. So we have x is greater than -3. On the other side, we'll go ahead and continue the same process, and we'll use the inverse operations to solve for the variable. So we have a 3x is less than or equal to 5, and then we're going to go ahead and divide by 3, and we have that x is less than or equal to 5/3, and yes, fractions are perfectly fine. Okay, so then we're going to go ahead and graph each of those on a number line, and we have them connected, so this is like an and inequality. Okay, so we'll make our number line, and we have the point -3, and the point 5/3. Okay, for the -3, we know that it's an open and it's greater than -3. So we can either use an open circle or you can use the parenthesis. And then we have less than or equal to 5/3, which means a bracket. And in this particular case, we are going to be shading between those. Okay, and then in interval notation, we can re-express that as -3, the endpoint here, and 5/3 is the endpoint on this side. So this says that the answer for that inequality is all values between -3, not including, and 5/3 inclusive. So any number that we pick between those would satisfy this equation. And you could quickly check with something like 0. So -4 is less than 5, which is less than or equal to 10, and that's true. Okay, so that's the first option, that you could break it into two separate problems. The second option is to deal with this as one problem. Okay, so you isolate the variable in this middle section. Okay, in order to do that, I have -3 here, so that means I would have to multiply by -3. When I multiply by -3, remember my inequalities are switching, so I'll just go ahead and switch those first. And now in the center here, I have p minus 2. Now whatever I did to this middle, I'm going to have to do to this side, and I'm going to have to do to this side. So that's the key piece. That's the trickiest part about leaving them as one inequality, is that people forget to apply the operations to all parts of the inequality. So on this side I would have a -6, and then on this side I would have a +3. And then I would go ahead and continue this process of isolating the variable. So I'm going to add 2 to the middle to undo it or get rid of it. But if I did it here, I also have to do it here and here, which is a little different than what we're used to. Okay, so now I have a negative 6 plus 4, a negative 6 plus 2, which gives me negative 4, less than or equal to p, which is less than or equal to 5. So that's the other option. You just have to be really cautious that you don't forget to apply it to both pieces. Okay, so let's go ahead and graph this on the number line. We have the point negative 4 and 5. Okay, now we have both of them are less than or equal to, so that means brackets for each of these values, and it's negative 4 is less than or equal to p, or p is greater than or equal to negative 4, so we're going to be going that way, and then p is less than 5, and so this is our solution area. In interval notation, that would be from negative 4 to 5 inclusive. Remember, the brackets are inclusive. Okay, so this is for inequalities where and is happening. And now we're going to take a look at an or inequality. The ors are very straightforward because you really only have one option for those, which is to solve them separately. So first we'll deal with this one on this side. And so I have 4x is less than 13, and then we'll go ahead and divide each side by 4. So x is less than 13/4. Okay. And then on this side, we'll go ahead and divide by negative 2. Again, when we divide by a negative, we're going to flip that inequality. And so on this side, I have x is greater than negative 3/2. Okay. Now, just as a reminder, when it's an or means either could be true, and the whole thing is true. With the ands, we have to have the overlap where both are true. Okay, so let's take a look at each of these, and then we'll determine our overall answer. Okay, so we'll go ahead and graph each of these. In this particular case, I have less than 13/4, right? So we have this open circle or parenthesis and less than. For this one, I have greater than 3/2. So I have this, and I'm going this way. Now remember, for an or statement, we said last week that you have the overlap, and in this particular case the entire number line is being overlapped. So for this, our final solution would be all of the number line, which means negative infinity to infinity. Okay, tomorrow in class we will practice putting all these together, and I'll be able to answer any questions that you may have after watching the video. See you then.